In this video, I will show you how to make a simple car battery charger by modified microwave oven transformers, plus a metal bridge rectifier. Step by step in the details. This is DIY transformer. That is a metal bridge rectifier with maximum 50 amperes capacity. The used LED set. A piece of metal sheet as a heatsink for the metal bridge rectifier. A pair of battery connection cables with alligators. A fuse holder with 30 amperes fuse in it. DIY made cables. All components and materials here will be used for making a simple car battery charger. This DIY transformer is made by 2 microwave oven transformers recycled. The details how to make that are in the video, how to make your own transformer, on my channel. In short, by using 2 coils combined which are from microwave oven transformers primary coils, as this DIY transformer's primary coil. The twins cables in red color is secondary coil, total of 28 turns. The primary has been connected to the AC power of 240 volt, however not switch on yet. The secondary has been hooked by a multimeter's AC voltage position. Switch the power on, the meter indicated, AC 13.3 volt. Switch the power off now. The metal bridge rectifier has been bolted on the heatsink. The LED set has been tied on the top, and wires connected to the positive and negative respectively as well. This is a diagram for the principle of the circuit. The LED set is here. The white wire connected to rectifier's positive terminal, which showed here from the diagram. The gray wire connected to rectifier's negative terminal, which showed there from the diagram. The LED set is from diagram. The 4 resistors are here from the diagram. This is a fuse holder. There is a fuse in it. Its capacity is DC 30 amperes. Here we go, all things have been installed and secured on a board. This is their connection diagram. Apart from the things initial indicated, a 3-pin socket and a heavy-duty switch have been installed for the convenience. From the diagram, the DIY transform is here. Metal bridge rectifier is there underneath the LED set. A 30 amperes fuse is there with its black holder. From diagram, 3 LEDs, with their 4 resistors together, as a LED set on the top. As we've known, a heavy-duty switch is here on the board. Those are the battery's negative, positive connection cables, with their alligators attached. From diagram, the input of AC 240 volt is here. Then plugged the power cable into socket, but connected yet. The transformer's secondary twins cables, which are the cables in red color connected to the rectifier's AC terminals. From rectifier's DC positive terminal to the fuse holder by a single red wire. From the fuse holder's other end gone through a screw then to the battery's positive alligator by a single red wire. From the rectifier's negative terminal connected to a secured screw on the board, by a single black wire. The heavy-duty switch is here. From a secured screw, a yellow wire to the switch, then from the switch other terminal through a black wire to the battery's negative alligator. Paying attention, the LED set white wire is connected between the fuse holder and battery's positive alligator. Its gray wire is connected to the rectifier's negative terminal. The reason of the white wire connected in that way is to make sure when the fuse burnt, the lead would go out. An example is following. Switch the power on, then the lead on. As a sample of the fuse burnt by taking the 30 amperes fuse out of its holder, then the lead out. Switch the power off. Charging a battery has been set up. The battery is here. This is the voltage and ampere meter to monitor charging condition. The charger's positive connected to the battery's positive, charger's negative connected through the voltage and ampere meter to battery's negative. Turn the meter on. 10.2 volt is the battery's voltage. The figure at meter's bottom and blue color will be the charging current. Switch the AC power on, then LED on. Now turning the DC switch on. The charging current is showing here. The input AC current is 1.14 amperes showed from the meter on the left. So, the efficient of the power consumption equals DC voltage of 13.8 volts times current of 5.2 amperes over AC 240 volt times 1.14 amperes equals 71.76 over 273.60 equals approximately 0.262 equals 26.2%. Now two different batteries have been charging together by this charger. Positive terminal to positive terminal connected by a jumper LED, and so did negative terminals. No problem. No problem whatever. Now you've known how to modify recycled microwave oven transformers to make a simple and powerful car battery charger. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.